Alright, so in this video I'll try to talk about some exponential function and how that thing works, what is that exponential function, and some of the basic characteristics of exponential function. Exponential function is a function which we define like this: f of x equals to c e to the power x. This is how we define exponential function in terms of x, and this c is some constant number which is called the initial value of the function, and a is called the growth factor, c is called, this is the initial value of the function, this a is called the growth factor of the function, and definitely this c cannot be equals to 0. We cannot make this c 0, and a has to be greater than 0. A has to be greater than 0. A cannot be equals to 0, or even a cannot be equals to 1 also, because if it is 1 then we have some other interesting outputs. And the value of a, sometimes the value of a is between 0 and 1, and sometimes the value of a is more than 1. So this c is the initial value and a is the growth factor, and let's check actually what does it mean, how it works, etc, etc. Let's look at some data, x, y, let's say -1, then 0, 1, 2, 3, some this kind of thing. And if we look at the data, let's put some data, and we can put the data this way. Let's say 2, 4, then 8, 16, 32. This way we define some data, and if you look at the value, then you will see this data is actually, these data are exponential data. Why? The reason is, if you look at this value, see 32 divided by 16, then we get some value which is 2. 32 divided by 16 equals to 2, and everywhere we have this same ratio. 4 divided by 2 equals to 2, 8 divided by 4 equals to 2, 16 divided by 2, 8 equals to 2. This is called the common ratio, and this is the value of a. This is called the growth factor. Growth factor is, you can do it here also, like 4 divided by 2 also. 4 divided by 2 also you will get 2, which is also a. You can get a from any two numbers, successive numbers. The second number divided by first number will give us the growth factor, and the initial value is the value here at x equals to 0. At x equals to 0, what is the value of y? That is the initial value. So this is the value of c, and this is the value of a. Then, therefore, for this data set, what will be our exponential function? For this data set, our exponential function will be fx equals to, you can see the initial value is c, so we have to put 4 here, and then we have to put our value of a, which is 2, then 2 to the power x. So this is our exponential function for this data set. And you can see, just this is kind of funny, but you can see you cannot multiply this 4 and 8 because they are basically different thing. This 2 is the base of the x, and 4 is the coefficient, 4 is the initial value, so they are two different things. Don't try to multiply it here. If you draw the graph of this kind of functions, let's try to draw this kind of functions. Let's try to draw it. So if we try to draw it, 1, 2, 3, 4, -1. Oh, this direction I need really big values. Let's see, okay, 1, 2, 3, 4, 5, 6, blah blah. So for 0 it is 4, so 1, 2, 3, 4. This is the value. This is the value. For minus 1 it is 2, this is minus 1, it is 2 is here. For minus 1, 2 is here. For 2 it is 16, 1, 2, so 16 is actually going out of my values. Let's say somewhat here, I'm sorry for this. I mean, this is going out of the graph. And if we look at minus 1, minus 2, then also actually we can see where the graph, where it will go. So for minus 2 it will be 1 actually. Let's plot this. If we go back for minus 2, what it will be? It will be 1. For minus 2 it will be 1 because 2 divided by 1 equals to 2. So our ratio will remain same. To make the ratio same, we can actually go back also, because it is some series. So see, for series it is very easy to go back. So what we have here is the other value will be 1. So you can see, I think you can see the basic shape of the graph. You can see the shape of the graph, and that is the objective here. This is our, as you know, this is our x-axis, this is our y-axis, and if we want to draw the graph, then the graph will look somewhat like this. One, two, three, four, 2. We have values there. Then just graph will go this direction, and up direction also graph will go. So this is, there was one value, this is one value. So the graph is somewhat like this. This is how the graph will look. This is how the graph will look. So now the interesting thing is, can we draw some more conclusion about this graph? Like, what are the conclusion that we can think about from this graph? What are the properties of this graph? If you look at the graph, first of all, if you look at the graph, then you will see, you can actually see it. First of all, this is some kind of increasing graph. It is some increasing, the values are increasing. So this is some increasing function. This is some increasing function, you can see. Then what is the domain of this function? You can see the graph is going this direction forever, and this direction also forever. That means in the x direction, in the y, positive x direction and the negative x direction, in the both direction, the graph is going forever. So this is giving us some idea about the domain of this graph. So domain of this graph will be all real number. That will be the domain. All the numbers will be the domain of this graph. What will be the range of this graph? Range of this graph is actually from 0 to the plus infinity. Okay, I mean, and 0 is not included. So range is y such that y is greater than 0. This is the range. Then you can see basically this is the asymptote of the graph, because the graph is actually coming closer and closer to this line, x line, but the graph is not going to touch it. So this is the asymptote. So another thing is asymptote. Asymptote is y equals to 0, or you can say x-axis. Both is correct. X-axis. So asymptote is x-axis. What are the things? What else we can decide about this graph? Intercept. So see this intercept. Intercept of this graph is this point. This point is the intercept, which is 0, 4, 1, 2, 3, 4, and 0. So intercept is 0, 4. They are the intercept. And this graph do not have any. We should not talk about. the common points. Normally, if the graph is like um, if we write the graph in terms of a, then there is some common points also for the graphs. Let's not that's not the case here. So you can see these are the some behavior of this data and this graph. In fact, let me now tell you. In fact, for all the graph where a is greater than 1, for all the graph where a is greater than 1, a is greater than 1, for all the graph, let me write it here. For all the graph where a is greater than 1, if a is greater than 1, for example, in this math a is 2. Suppose if you get a is 3 or some other things. If a is greater than 1, always our graph will be like this. Okay. Always, if a is greater than 1. And if a is between, let me write another thing. Suppose if a is between, let's say a is greater than 0 and less than 1. A is greater than 0 and less than 1, then the graph will be like this. Then the graph will be like this. For example, if you want an example of this function, this kind of function, let's say fx equals to 1 by 2 to the power x. This kind of function. For this is 0.5. So this is why I said 0 to 1. Between 0 and 1. Between 0 and 1 is 0.5. 1 by 2 means 0.5. So this kind of functions graph will be this one, and this kind of functions graph will be this one. So this is how these are the basics about the exponential function, like how all these things works, the function works, and the entire things with some data and some graph, properties of the graph. Basically, you can actually interpret the properties of the graph. This one's properties and this one's properties is similar. This one's properties also a lot of things is similar. For example, range is similar, domain is similar, just it is decreasing graph. Intercept, you will get some intercept here. And what else? Asymptote is same, x-axis is the asymptote, then it is decreasing. Yeah, so basically if you look at the graph, if you understand one graph very nicely, we can actually decide about the other graphs. All right, thank you very much.